Good afternoon, everybody. I'm Chris Kaufman. I'm with the Southwest Florida Water Management District, and I've been working on our swim seagrass mapping program for about the last 10 years. And so I was going to bring to you today some of the updates on our most recent mapping effort, which was in 2012, as well as some of our data from the long-term overall project. So the purpose today was, like I said, to bring an update from Swiftwood's seagrass mapping program. We began mapping seagrass in 1988, and we mapped seagrass generally every 2 years since then. Currently, our 2014 mapping effort is underway. It is starting in December 2013 through January of 2014. We collected our aerial imagery, and that project is ongoing. So the objective of SwiftMud Seagrass Mapping Project is to accurately document and map the extent and distribution of seagrasses in our 5 Gulf Coast estuaries. So what is seagrass? It's a marine angiosperm, which generally is, the easiest way to explain it is a rooted marine plant that lives completely submerged underwater. The seagrass habitats themselves, the beds that they create, become essential marine habitat. As habitat, the seagrasses will trap and stabilize sediments and floating particles. Like we discussed earlier today, seagrasses cycle nutrients and oxygen throughout the system. They're part of our food chain in the marine environment, and they also provide, the physical leaves themselves will provide shelter and protection and create feeding and spawning grounds for recreationally and commercially important fish. So why is it important to collect data on seagrass? Well, seagrass for the Florida community and for those interested in fishing in the state of Florida, the seagrass community itself will support the multi-million-dollar fishing industry we have here in our state. For resource managers like myself and others in the room, what we do is we'll use that seagrass data as a resource management tool. So seagrass, because it requires clean water and clear water to survive, its presence in the system becomes essentially a vital indicator of bay or harbor health. So if seagrass is thriving, it's because it's getting the light it needs through a clean and clear water column, and its distribution essentially will help us track bay health through different concepts you saw earlier today, such as the numeric nutrient criteria setting that we created in the state, making correlations between the distribution of seagrass and water quality. And the Charlotte Harbor National Estuary Program a few years back created their own seagrass targets for their bay segments, and I will show you some of the results of our data in comparison to the targets that were set. The targets that they set a few years back actually used the SwiftMud district data to create and set those targets, and then our future ongoing work that we've been doing will be used to track how well we can achieve those targets. So the overview for the talk, I'll briefly go through the district's mapping program, our methods, the results of our seagrass map data, and just a very brief summary. So the project extent for the SwiftMud effort that we do every 2 years extends from St. Joseph Sound, Clearwater Harbor up in the north, Tampa Bay, Sarasota Bay, Lemon Bay, and then here in Charlotte Harbor. And then what you'll see here in the next picture. So generally what we do is we cover in our district 2,500 square miles of area to map seagrass. Here is a picture of the estuary program. You can see that the line I'm drawing right here is about the SwiftMud jurisdictional boundary. So we only go as far as essentially Cape Cay's area along the Lee County line. So the district is only responsible for, the Southwest Florida Water Management District is only responsible for the tidal Keysamayaca River, Charlotte Harbor proper, Lemon Bay, and then that Cape Cay's and Placida Harbor area. Everything south of that is going to be the South Florida Water Management District responsibility, area of responsibility. Their most along with a 2008 map that SwiftMud did. And they also have partnered with us for our 2014 effort. So we have currently collected, for the partnered project, aerial imagery for this entire study area. It's been a few years coming, and so we were able to coordinate. So it's a very good thing. It's very exciting. Hopefully in a few years I'll be able to report to you guys on that. So today I'll be reporting data just for Charlotte Harbor proper, Lemon Bay, and the tidal piece in Miami. So very quickly, the district seagrass mapping program has historically used aerial photography to map seagrass. It's a tradition, and because of the status, well, I'm sorry, not the status, but the trends that we've created using these methods, we will continue to map using digital aerial photography and manual photo interpretation that I'm describing today, so that it's a long-term program, it's consistent methods, and so we try to maintain this so that we can also maintain the trends and not introduce any artifacts into the data that we've been collecting. So what we do is, for that entire study area I showed you, we collect in the winter months 1-foot digital aerial imagery, and we use, that's just a Cessna airplane survey with a very high-tech camera doing that for us. And then what we'll do once we have this imagery acquired, this is a picture of seagrass, and then you can see these yellow lines are the manual photo interpretation. That's the delineation of the seagrass. So this is literally the seagrass map. We have trained consultants, which are biologists and GIS analysts by trade that have a lot of years doing this type of work, draw these maps for us. And you can see that different benthic features are classified. They're both seagrass, but what you can see is this is a patchy seagrass polygon, and these areas are considered the continuous seagrass classifications. So we do map two different seagrass classifications, patchy and continuous. Those definitions are readily available in our final reports if you have interest in those. The next step, once we've done the photo interpretation and we've done the actual map making, if those analysts have questions about data, we go out and we do field verification. So any questions, any confirmations they want to make, we take them out into the field so that they can see what is in the picture corresponds to what they're seeing in the real world. And for our 2012 effort, we went out to, within the 5 estuaries, we went out to nearly 1,000 locations. And this is point spot checking, so we'll tour an area so that these consultants get a very good idea of what the signatures in the pictures are telling them and confirming that it is in fact seagrass. The next step for the map is once it's completely made, the district does an independent assessment of the map product. We go out in the 5 estuaries and we document 550 different locations, and we test that data against the map itself. And for our most recent product in 2012, it had a 96% accuracy in classifying seagrass. Oh, sorry, additional pictures. That's an example of ground truthing. Now for the CHNEP's boundaries, we know that the NEP covers 350 square miles of estuarine waters in 8 regions that are subdivided into our 14 segments. I will only be reporting again on not all of those 14 segments. I think I have 8 or 9 to report. And again, the district covers Peace, Mayaca, and Charlotte Harbor proper. Now, beyond the divisions that we make over jurisdictional boundaries, what we do is we divide the map that we make for the entire area into reporting units. Just easier ways to absorb the data so that we can also analyze them differently for the different regions of the bay. To make it even more complicated, the district creates its own reporting units. Those are the segments that you see here. We've got Mayaca River, Peace River, and those are the tidal portions of the rivers only. And then we have Lemon Bay, Placida. It says Turtle Bay, Bull Bay, we also call that Cape Bays. Western and Eastern Charlotte, and then you can see the distinction between Eastern Charlotte, North and South, and Southern Charlotte. These are portions, these Florida jurisdiction, but because of the way we collect our mapping data, our aerial photography, that data is available to us, so we go ahead and map it. We've been mapping it since 1988, so we want to carry forward with the trends, so I will be reporting that data to you. But everything here north is SwiftMud data. And I'll show you shortly how the CHNEP divides up the mapping products into different segments. So I'll show you data both ways. Essentially the same data carved up differently. So overall, for the long-term program, our program started in 1988. You do see data here from 1982 that was conducted by FWRI, the Research Institute, back in 82. So I just figured I'd include that data as well. But as you can see, for Lemon Bay, we're at nearly 19,000 acres of seagrass bay-wide for that area. It is above the 1982 and 88 total coverages. And you can see here that we have recorded higher amounts of seagrass in the past, but this is an example of when you change methods, you can introduce interesting things to your data set. The 1996 data was collected in the spring instead of the winter, so there was a different extended distribution of seagrass. So in general, when people in this area or scientists in this area are analyzing our seagrass data, they most often throw out the 1996 data when you're doing trend analysis because that data is essentially from a different time period. It is not as consistent as the rest of the data set. So although it is helpful information in the context of wanting to watch a trend, we generally do throw it out. So as you can see, in 2012, we've had up and downs, most likely with El Niños, with heavier rainfall years than others can affect seagrass and seagrass mapping. So 2012, we are seeing some of the highest, or the highest coverage besides 96 than we have in the previous time. Now, this is some information from our most recent mapping product in 2012. If you can't read the pie chart, all it's telling you is that for the seagrass in Lemon Bay, 64% of that is classified, the majority of it is classified as continuous beds, whereas 36% is considered patchy seagrass. And then you can see here I've shown trends or the changes between the 2010 and the 2012 map. So based on the most recent two maps, our seagrass, the continuous coverage did decrease by a small amount, where the patchy seagrass classification increased. And as you can see at the bottom, between 2010 and 2012, we saw a very minor increase in coverage for 2012, a 2% increase, which generally tells you that the system is stable. And here's an example of the map product itself. You can see Lemon Bay. What you're seeing here in the yellow is locations where there was no change in seagrass distribution between 10 and 12. The red areas are decreases in coverage between 10 and 12, so we did not map seagrass in the red locations in 2012. And the green locations closer to the pass, not great distinction on the screen, but these areas, those were gains in seagrass. So we did map seagrass in 2012 at those locations when we had not previously in 2010. The changes you see here, other than the narrower, more restricted portion of Lemon Bay, is not unheard of to see losses in those locations because that is a more restricted area of the bay. So over the years, we have seen losses happen in that exact same spot time and time again. So on to, sorry. I will try to yell. I don't know if you guys can hear me. But for Charlotte Harbor, as you can see, we have higher numbers than we did in 2012. And again, the 1996 data is an artifact. I'll try this one. Okay. So again, 2012, we have higher numbers than we did in 82 and 88. 1996, again, that data was collected in the spring season, where it does kind of mess with the trend a little bit. Again, you see here we have had some dips and some falls in seagrass coverage for the system, generally resulting or correlating to wet years in 1999 and dry season. We had the higher coverages in years like 2006. Now for the most recent data, again, and I checked the numbers, it's the same split for continuous to patchy as Lemon Bay. So the majority is continuous. 64% of the seagrass cover in 2012 was continuous. 36 was patchy. From 10 to 12, we saw almost a 4.5% increase in seagrass coverage for the maps, and both patchy and continuous classifications increased over those 2 years. This is busy, and really the take-home message here to see is that the majority of the increases were recorded in eastern Charlotte Harbor between 10 and 12. And one of the most surprising is the Peace River increases of 91.6%, and I'll show you examples. Really quickly, this is just a breakdown over the last couple of years using the district data, showing you that there's, this is just showing you by segment the changes over time since 2006. Nothing really dramatic or terribly interesting about it. They're in general increasing over time. Seagrass coverage is increasing in most of the segments over time. Here's an example of the bay of the Cape Hayes area, and you can see that most of it is stable. You can see that the increases in eastern Charlotte Harbor South, you may not be able to tell, but they're all along the deep edge of this bed. This entire thing generally has an increase in the deep edge extent. Increases in eastern Charlotte Harbor North were closer to the shoreline. This is the increase that occurred in the Peace River segment. So hopefully this will show up. So you can, hopefully you guys can see that this was a sand flat with no apparent signatures in 2010. And here are the signatures that we were able to document for seagrass in 2012. A very apparent increase in seagrass for this location. We saw these are just some simple changes in the Mayaca River with some losses. This area was interesting to note in the Mayaca River because there was a significant coverage of filamentous algae there, causing that signature. That actually is not seagrass, and we went out and field verified that, and so that's why we can report that confidently. So this is the way that the CHNEP breaks up their study area into segments, into bay segments. I just want to quickly show you that, so that I can leave you with district data compared to the seagrass targets for the NEP. For the 4 bay segments, Donna Roberts Bay, Upper Lemon Bay, West Wall, and Lower Charlotte Harbor, the 2012 data shows that we are meeting and exceeding our targets in those 4 regions, or those 4 segments. The other segments, Lower Lemon Bay, East Wall, and Cape Hayes, we are 90%. Those values in 2012, the coverage is 90% of the targets. Where we're still not meeting targets are the tidal piece of Mayaca River, which those are 2 very difficult places to map, and so it's essentially understandable that we have yet to meet those targets. So just in summary, SwiftMud has been funding this program, initiating the program for the last 25 years. For all of our estuaries, we have 10 plus maps, so we can now start to actually run some statistics on the data set. And we supply this information to the public and scientists, so if you are GIS friendly and you want to use the maps, you can get those from us. If you'd like to see just map products themselves, nice pictures, we can provide those as well as acreage estimates like I was showing you today. And just an update, we should have the 2014 product for you in January of 2015.